For those who are not familiar with Eimear, let me pull up your bio here. And yeah, Eimear is a senior data scientist at Unbounce. And Eimear, you're gonna have to take a minute to tell us a little bit about Unbounce. I know it's a really cool company. But Eimear leads a machine learning prototyping team. She originally comes from a bioengineering background, graduating from Imperial College London. And for the past 5 years, she has worked on ML projects in multiple industries, including wearable tech, insurance, and e-commerce. Thank you, Eimear. With that being said, I'm going to get off screen and let you join. And then I'll let you know in the chat here if you have any trouble sharing your screen, okay?
Great. Okay, I'm going to kick it off. So like was said already, my name is Eimear Nolan, and I'm a senior data scientist at Unbounce. I'm here this evening to talk about how to diversify your way to rapid machine learning experimentation, or how multifaceted nimble teams will bootstrap your machine learning returns. So I think my introduction is already given. I actually started out as an electronic engineer, started in Dublin, did a research stint in biomedical engineering in UQ in Brisbane, and then got my master's in neurotechnology, which is a combination of electronic engineering and neuroscience from Imperial College London. And for the last 5 years, I've worked in various different industries in machine learning. A little about Unbounce. So Unbounce is a leading landing page builder and conversion platform for marketers. So we really help marketers get the most out of their campaigns without spending more money or relying on developers. We have over 200 employees in Vancouver, and we have a growing office in Berlin. And we host roughly about 500,000 pages at any one time. A little about the platform. The platform is drag and drop, so you can create landing pages without needing a web design degree or without having any developer skills. We have loads of templates you can use, and you can publish fast and publish to your own domain or WordPress. So today, what we're actually going to go through, we're going to talk about machine learning at Unbounce. We're going to talk about how we set up our team structure. We're going to talk about why we prototype machine learning in the first place, why it's actually important. We're going to go through a case study of our most recent prototype, which is the copy optimizer, and go in depth into two prototyping components: the model, how it's deployed, and model broker, which is native to Unbounce and made by our data engineers. Finally, I'm going to talk a little bit about how we measure success of our prototypes. So machine learning at Unbounce comes in two flavors: customer and market facing, which is really where we try to give insights to the customers about landing page copy, landing page design, and the traffic that's going to their landing page. Decision science is really where we use the data to gain insights about our business, things like churn models. Our biggest customer and market facing feature at the moment is called smart traffic. So smart traffic is a machine learning algorithm that aims to depreciate A/B testing. So instead of creating multiple variants of a landing page and using A/B testing to test them out, you can create multiple variants of a landing page as many as you want, and smart traffic will auto-route people to the landing page they are most likely to convert on. So our team at Unbounce in machine learning is made up of 3 sub-squads. So R&D, they're really in charge of model exploration, model training, and hyperparameter tuning. The work that they do gets funneled into us on the prototyping team. So we create prototypes, bring them to market, and see how much value they actually have. And then the results from those prototypes go into insights, and they run analysis on the prototype results and communicate those results to stakeholders on other teams. Our senior team then are made up of our director of data science, our product manager, and our UX UI lead. So why is prototyping actually important? Well, machine learning has really created this Pandora's box amount of use cases that you can actually develop for, but finding which ones actually have valuable benefits associated with them is actually quite difficult. So a study from New Vantage in 2019 stated that about 77% of data science projects actually gather dust after the first year, so they're never really used again. So prototyping is a way to reduce your uncertainty around an idea by spending the minimal amount of time doing that. So you can fake some of these machine learning concepts before actually committing to developing them and perfecting them. We had a case study in Unbounce last year where we generated headlines. And instead of perfecting that entire machine learning system, we built a model, generated headlines. We actually manually separated them out between good headlines, bad headlines, picked a subset of our customers, showed them the headlines we produced, and saw how they engaged and interacted with those headlines. And that really made us more informed as to what to actually build in order to get value for our customers. Lastly, it also helps us data scientists remain cognizant of how our models really will be used, not just how they're created. So I think we all know that data scientists get very engrossed in model architecture and model training and how it all works. But ultimately, we always need to keep in mind why we're doing it. And really, by prototyping on a regular basis, we always bring non-machine learning practitioners into the room, and their opinions are really valuable and lead us to create better balanced prototypes. So this is my favorite meme about data scientists, because data scientists will always solve a problem with a data science solution. And ultimately, sometimes that's actually just not necessary. So we had a project last month, which was about, it really involved getting an industry from a landing page copy. So a group of data scientists got together, we discussed models, latent Dirichlet models that we trained for maybe a month and look at for a month. And our product manager and our UX UI lead joined the conversation and said, well, we could just ask the customer what industry they're from. So that saved us a month of work that we really didn't need to do. So our prototyping team is made up of 3 people. We have a data scientist, myself, a data engineer, and a front-end developer. We can typically get a prototype into production in about 8 weeks, depending on how much model design needs to go with it. Our prototypes come in 2 flavors. They can be straight to market, where anybody can actually access it and try it out, or they can be in-app, where it's kind of put beside our platform and the customers on our platform can try it out. So now that we have our team set up and we know why we're prototyping, ultimately we want to know what's the best way to get our prototypes out to market and investigate really how much value they have. So our prototypes in Unbounce, they have 4 components. They have the client, which is really where the user comes in and interacts with it. The security or orchestration, which is the public gateway to model broker. Model broker, which does the mediation between the outside world and the model. And finally, the model, which gives back the responses. So to look at these 4 components, I'm going to use an example of our latest prototype. It's called the copy optimizer. And it's based on a fact that we found at Unbounce, where copy is actually twice as important as design on a landing page. So using this fact, we really wanted to help our customers create high converting copy. So we created this prototype, and it was a web page where users could come in, copy and paste their text, and we would give them back suggestions on words that our model would have predicted would really give not great conversion rate. So the words we would give back would improve their conversion rates. How we did this was by using a model called BERT. So BERT is a state-of-the-art natural language processing model from Google. It's a language model, so it really tries to learn the semantics of a language. And to do this, it's pre-trained on 2 general language tasks. So the first is a masked language model, which basically means it ingests a corpus of text, it masks a certain percentage of the tokens, and then it tries to predict what that actual word is. So this is really a way to mitigate not having to label words and train off their meaning. The second general language task is called next sentence prediction. And basically, BERT just takes 2 pairs of sentences. The second sentence may or may not be removed. And BERT is asked whether the second sentence actually follows the first and is appropriate for the first. Once those 2 general language tasks are done, you can then actually fine-tune BERT to your own purposes. So in our case, we fine-tune BERT using landing page copy. I'm not going to go into too much more detail about BERT because it's a whole presentation by itself. But there is a really great illustrated post by Eimear that's tagged at the bottom of this page, and you can access that and take a read of it if you want more details. So our prototype actually contains 2 BERT models. The first BERT model was made by our R&D team, and it basically predicts conversion rate from text. So it's been finely tuned with about 50,000 landing page by our R&D data scientists. The second BERT model is really an out-of-the-box model, and it suggests replacements for masked words in a sentence. So both of these models really rely heavily on the Hugging Face library, which is basically the main Python library for implementing natural language processing models. So now that we have our model and we've tested it, we fine-tuned it and we know that it works, we want to productionize it and really put it as a real web service. So what we do in Unbounce is we train the model offline using Jupyter Notebook on Sagemaker. We wrap the inference logic into a Flask application, we Dockerize it, and then we host that container on Sagemaker hosting services. What this actually looks like in the real world is something like this. So I know it looks like a complicated diagram, but it's actually not that bad. So the diagram above the horizontal line is really to do with model weights. So any data that's actually needed by the model to run is termed by AWS as a model artifact. And in BERT, those artifacts are really model weights that belong to BERT. So what we do is we upload those model weights as a model artifact to an Amazon S3 bucket. After this, we focus on the Docker container that's used for inference. So in our case for this, we have an Ubuntu container with Flask, and our machine learning framework is the PyTorch framework. Once we're happy and have tested this container locally and it gives back the responses we want, we can upload the container to Amazon ECR. So with those 2 components in the AWS cloud, the model artifacts and the container, we can create what's called a Sagemaker endpoint. And that's really the last part of this deployment. The Sagemaker endpoint is really the single entrance to getting inferences from a model. So you'll finish the deployment with this Sagemaker endpoint. And actually what sits behind it is a number of ML compute instances. This can be scaled to however many instances you want, depending on your application. Sagemaker then runs the Docker container on those instances. And in Unbounce, we then register the model with Unbounce's internal model broker. And this basically just creates an API path for us to get responses from the model. And that's model deployment. So really, it's done with a combination of Docker, Sagemaker, and Flask. Next, I'm just going to talk about Model Broker. Model Broker was made by our data engineers, and really it's the standardized point of communication for all our machine learning models, and it follows an asynchronous workflow. So what this actually does is that it takes a task for inference from the client and it adds it to a queue. The dispatcher, which is another portion of Model Broker, takes the task from the top of the queue and sends it to our model on Sagemaker. The model runs, gives back an inference. Model Broker collects this inference and then sends it back to the client. So in our prototype, we only had 1 model, but in reality, you could actually evaluate multiple models in parallel using this architecture. So this architecture is loosely based off a rendezvous architecture, which was created by Ted Dunning and Ellen Friedman. And it's in a book called Machine Learning Logistics, and it's definitely worth a read. So that's Model Broker. Really what it does is it facilitates calling the model, it validates your input, it supports testing your model in parallel with multiple other models if you need to, and then it produces your inferences asynchronously. And that's the second portion of our prototyping components. So Model Broker is made with a combination of Docker, Kubernetes, and Flask. The other 2 components, the security and orchestration and the client, are really more straightforward software engineering components, so I'm not going to go into depth on them. But our security and orchestration is created with Docker, Kubernetes, and Flask as well. And our client, in this case, for this prototype or web page, is made with Node, React, Google Analytics, and Hotjar. Lastly, I'm just going to talk a little bit about how we measure our results, so how we know that the customers actually find this prototype valuable. So for us, we use a combination of Hotjar and Google Analytics. So Hotjar is really an explicit form of feedback where we add a survey to the web page and it has a ranking of 1 to 10, and customers can go in and if they want to give back feedback using that form. The other implicit form of tracking that we do is using Google Analytics. So we track things like page visits, like button clicks, and really that gives us a form of implicit feedback. So in this case, for the prototype, because we rewrite text, the copy text button gives us feedback on if the user thinks that text is valuable. Because if they copy it, then really they think it's valuable. So where do we go from there? Well, if your prototype is a success, then we can enter into a partnership with our feature engineers and create it properly and put it into production. Model Broker actually makes this a lot easier because the infrastructure is very standardized. So there's very little tech debt going from your prototype to your actual production feature. And if you fail, well, it's prototyping. So failures really are called learnings. It's not really failure because you've committed the least amount of time possible to evaluate this idea. So really what you can do now is iterate on that. You can either produce a better prototype with this information or go down a different path and spend your time on an idea that's actually going to come to fruition in a better way. And that's it. Thank you very much. Anybody have any questions? Okay, so the question is, do customers tend to use or gravitate more towards the website rearrangement feature more or the text creation feature? A little bit of both, depending on what they need. And the text creation feature, I suppose, if they're having more difficulty with text and copy and they don't have a copywriter on staff, it's probably a good thing to use. Okay, so the question is, how might you use the Sagemaker parallel models in future? Well, really in future, what we're looking to do is maybe when you put a feature into production, you can evaluate multiple models in parallel, as in the model that's already in production may need to be replaced. And to replace it, you really want to compare with your new model as well. So you can do that parallel comparison of your model that's in production and the model that you want to put into production, but you're not really sure if it's better or not. So that's really where we would see it being used. Okay, so the question is, has your team taken a look at GPT-3 and think it might be feasible? So we've signed up for the API access. We unfortunately don't have it yet. We do use GPT-2 in some of our research, and that's really the most that we use GPT-2 for. So maybe in the future we'll use GPT-3. It's a pretty impressive model, but we'll see if we actually need it. Yeah, so it's Machine Learning Logistics. It's by Ted Dunning and Ellen Friedman. So you'll probably be able to just get it from the authors. I think it's published by O'Reilly. And it's actually only one chapter, the rendezvous architecture. So I think it's chapter 3 in the book, and it's pretty short. There's also a really good Medium article by Zoopla. Zoopla, they're a real estate company, and their lead data scientist, they explain it really, really well. So the question is the model broker similar to a model registry? And I'm assuming it has similar input formats. Yeah, it's really similar to a model registry. So what I mean when I said that we register each model through Model Broker, that's really what I mean. You standardize that registration process and you register each model. So it keeps it very standardized and very easy to use for our software engineers. So when they put it into production, they can really just treat it as an API with a black box behind it full of machine learning that they don't really need to know anything about. Glad you found it. Okay, so the question is there any interesting insights that can be gained from images? You have that feature for copy text, which can indicate interesting parts of text. Have you explored such a thing for images? It's actually on our to-do list. We haven't done it at the moment, but we probably will be looking at it in the new year for images, definitely. What other things do you consider as well as BERT? So I think our R&D team looked at Facebook's competing model with BERT as well. I think it's called XLMNet. And we ran comparisons of the two of them and also ran ensembles of the two of them to see how they would perform. So ultimately, BERT came out on top, and that's really what we use at the moment. But that doesn't mean to say that we might change that in the future if some other model comes along and is better. Do you prefer Sagemaker or not really any difference? I actually really like Sagemaker. At the start, it seems like a pretty big learning curve, but once you get in on it, it's pretty intuitive and you can do very powerful things with Sagemaker. And what's nice is that a lot of other companies use Sagemaker too, so all their development bugs don't really exist because so many companies use it. It's a pretty well created tool at this stage.
All right, Eimear. Anybody has any questions? Head quickly. That was fantastic. I really appreciate you going through that. And if you're okay to share that, that's a lot packed in there. So what I can do, regardless, is some of the links that you've had on those pages. I'll take some of those links and we can send those off to everybody afterwards, because that was really cool. Yeah, thank you so much, Eimear. I really appreciate it. Thank you for taking the time, and I hope to have you back as well.
Great. Thanks for listening, everybody.
Yeah, you're most welcome. And thanks, everybody. We're going to wait. We have a couple minutes here, and then the next talks will be kicking off shortly. Okay. Thanks.
Have a good evening.
You too.